So I'm going to demonstrate how to collect a dissolved gas sample that we would analyze for greenhouse gases such as methane, CO2, and nitrous oxide. And the major pieces that you need are a 60 ml syringe with a stopcock and a tubing extender. You need evacuated excitainer vials. So these are 6 ml vials that have been under vacuum, have no gas in them, and are capped. And you need a tub to do the transfer in between the transfer gas of helium, and you'll need a transfer syringe with a needle attached to it, and then you'll need the gas itself. So we take gas bags into the field. These are basically very expensive balloons that are filled with helium. So make sure if you have them in the field that you have them anchored somehow, ideally, taped down. We use buckets and fill them with helium. That one's not completely full, but it has enough for this transfer in it. And so the first step is going to be to collect the sample, and then I'll bring the sample back here, and then I'll add the helium gas to the water sample, and then we will extract the gas and transfer the gas sample into the excitaners. So we're going to collect the gas sample dissolved in the water by pulling back on a syringe, and you can see immediately there's a very large bubble that we want to displace. So I'm going to pull the syringe out and tap. There's also a bunch of little bubbles around the edge that we want to try to get rid of. So tapping works. You can also pull in a slight amount of more gas and then tip it to catch some of those small bubbles on the edges, and then tap it a little bit more. Dispel that bubble, that big bubble. And then when you have water completely through your extender tube dipping out, you want to go ahead and put it back underwater and continue to push that potentially contaminated sample out, and then slowly pull back. Slow pulling back motion is key, because if you pull back too quickly, you will pull the gases out of the water. So anytime you're working with gases and water, it's just critical to be really patient and slow movement so that you don't end up creating bubbles from the action of collecting the sample. Keep your tubing underwater so that it doesn't come up above and pull in a bubble. So I'm going to collect this to about 45 mils or so. And that is a good gas sample, or a good water sample containing gases. All right, so now we have our 45 mils of water without bubbles in it in this syringe. And I'm going to go ahead and put it in the water bath. One item we don't have with us right now is some way to measure the temperature of the water bath. That's another really important step of this. So if you have a YSI or some kind of a field meter that you can put in the water bath, do that and record the temperature, because the water temperature matters. So the next step is going to be to collect some extraction gas and transfer that into the water sample. So I'm going to use a 30 ml syringe for this step. Ideally, this is outfitted with the smallest needle possible, a 27 gauge or something like that. We have a much larger needle today than what we would use in the field, but for demo purposes, it's fine. So we're going to take a gas sample out of the bag by piercing the septa. We're going to pull back about 5 mils, and then I'm going to turn off towards the gas bag on the stopcock and push this rinse gas out the side port of the stopcock. Pull back another 5 mils. Again, rinse it out the side port and pull back another 5 mils. And then rinse out the side port. Now I'm going to pull back about 22 mils or so. We're aiming for 20 eventually, but we want to have a little bit of extra to be able to rinse out any tubing and stopcock. So I usually pull about 22 mils of gas out. And give it a beat. So just sit there for a second to make sure that the pressure equilibrates between the gas bag and the syringe. If you turn the stopcock like this and the piston on the syringe sucks in, that means that you had a slight vacuum in the syringe and you don't have the right volume of gas in it. And that can be an issue, especially if you're working with much smaller syringe sizes. So just make sure that when you turn the stopcock off towards the syringe, it stays at the volume that you intended to get, which was about 21 mils for me. So I'm going to go ahead and pull this out of the septa and have the stopcock off towards the gas sample so that it should be not coming into contact with the atmosphere, and then remove this syringe for this step. The next step is going to be to transfer the gas, the helium, into the water sample to extract any of the gases that are in the water and put it into the helium sample, which we can then transfer to the excitator. So this step we do underwater. And the reason for that is because it allows us to see if there are any bubbles, and it also prevents and protects against potential contamination from the atmosphere. So the first step of this is going to be to push the water sample down to 40 mils. So we only want 40 mils of water in here. I just collected a little extra just in case kind of thing. So this is at 40. The way you read a syringe is from the bottom or the very top ring of the black should be even with the volume that you're looking at. So we have 40 mils of gas, of water in that syringe. And then we want to do the same and get 20 mils of gas. So just expelling about a mil of gas to get that to 1. And you should see the little bubbles coming out, letting you know that that's being flushed. So we've got 40 mils of water sample in the 60 mil syringe and 20 mils of helium in the 30 mil syringe. And we're going to transfer the 20 mils of helium into the syringe containing the 40 mils of water to extract the gases that are dissolved in the water. And so the way we do that is by connecting 2 different stopcocks. So the stopcock is off towards the water sample here and is off towards the side port in the case of the helium syringe here, so that I can get it to the right gas level. So connect those using the lure locks by twisting them together. And then you should see the off towards both of the side ports. So the arrows should connect between the gas syringe, the 2 stopcocks, and then up into the water containing syringe. So we're going to push down on the gas syringe, and that's going to bubble up that helium into the water containing syringe. And depending on the status of your syringes, you might have to kind of help gently pull this back to get the 20 mils of space in the 60 mil syringe. So we start pushing on this and start to see those bubbles coming up. And I'm just using my thumb and hand on the 60 mil syringe to kind of gently pull back and allow space for that gas to come into the syringe. And then I'm going to go ahead and turn the stopcock on the 60 mil syringe off towards the sample so that it can't come into contact with the atmosphere. And you'll see your gas transfer step is complete. At this point, we would shake this for 5 minutes to be able to equilibrate any of the gases that are dissolved in the water with this new headspace that we have introduced of helium. And that is what we ultimately want as the sample.